Hey everyone, welcome to my channel. So now we are going to do another question of our DP series, that is max dot product of two subsequences. Basically till now we are doing all the questions of LCS only. So this is also one of the question of LCS. But for the next time I'll make another topic series. So this is the last question for LCS which we are going to do. So let us go through this question. So given two arrays nums1 and nums2, return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. So in this question we are required to return maximum dot product from nums1 and nums2, and we will be doing dot product of the same, and then we are going to return the maximum of them. Till now we were doing longest common subsequence, right? So here again maximum thing is there, and here somehow the thing is about the common. So because of that common only it will be becoming the LCS question, and how that is there I'll show you in the further example. A subsequence of array is a new array form that we already know, and here we know that 2, 3, 5 is these things we already know. Now let us directly jump towards the constraint. So basically the constraints are in such manner so that n square solution would easily work here, and even the numbers which are being given here. So yeah, each number can go from minus 1000 to 1000, so that even if we multiply at max 1000 into 1000, so it will be going till 10 raised to power 6. So that's why the range of the numbers is given in this image. So now let us go to this question. So here if we see for doing the dot product, let me show you the example. So for doing dot product, either we can do 2 into 3, or we can do 2 into 0, or we can do 2 into minus 6, right? Means one time we are fixing the 2 and checking for all the all which are being there in the nums2, and then we can also do other way around, that we are checking for 2 into 3, then 1 into minus 1 into 3, then minus 2 into 3, and then 5 into 3. Means any way around could be there, right? Means either we could fix the first one, or we could fix the second one, or even this thing also be there that we are fixing both of them. Basically 2 is also fixed and 3 is also fixed. Then in the next one 1 is also fixed and 0 is also fixed. So like this manner also we can go, right? So somehow here it comes out to be selecting one and non-selecting one. So it somehow that it becomes a question of inclusion and exclusion, right? So in all that context, now how LCS comes into the picture. So here when we are either including this or including that, and there is one more thing which is being given to us, that we could also check that whatever was previously stored, that also, and what is the next one which would be stored, that is also being there. Then also we can get a direct dot product which is the maximum. And in other example if we see here, they are just taking for the one only, that is one from the nums1 and one from the nums2, right? So that's why here directly we are checking for nums1 of I and nums2 of j. That's the thing which we are doing here. So these are also some of the examples, right? Now let us go ahead that how we are required to check for the that how we are going to even come up with the recursive solution or DP solution. This is a DP solution, that's for sure, because from the first example itself we can see that we are adding up from the previous one also, and even as per the question that we are required to figure out with the maximum dot product. So we are required to try out all the possible combinations, and when it comes the part for the possible combination, so it simply depicts that it is a recursive solution. And as per the as per the constraints given, so their recursive solution won't work. So surely we would be required to memoize it, and when the memoization comes into picture, so surely there would be a bottom DP also. So that's how this question becomes the question of DP. But surely this question is of inclusion and exclusion, that we can clearly see. How it is a question of LCS or not, that we will come afterwards, means when I would be coding, then you could clearly see that how it is. And even from the fact that we are including or excluding, that also depicts that it is a question of LCS, because we are figuring out that what is common among them, means common for the nums1 and nums2 which is there, that we are already figuring out here. So although not directly as LCS, but still the pattern which we are following here, from we are selecting from nums1 or not, nums2 or not, that simply reflects that it is somehow following the path of LCS. That's the thing here. Although in LCS what we were doing was, we were just checking that if nums of 1 or nums of 2 are they equal, then we were doing some operations, as if they are not, then we were doing some operations. But in this question, we are not doing if-else conditions like that, but we are directly moving ahead, selecting from the nums1, selecting from the nums2, basically the sub portion of the LCS, that is inclusion and exclusion question, that is this question. And that is how only some portion is similar to LCS, not the complete portion. That's the scenario here. Now let me show you that how we can come up with the recursive solution for the same. So for recursion, what the things we are required with? We are required with the recurrence relation, and before that we are required with options, right? And after that we will check that what base case we would be selecting. So for that thing, let me show you that how we can do that. You have already seen that what sort of examples could be there. Now let us come to the coding approach of this particular. Let me show you. So here you can check that nums1 and num2 is there, right? So options what we are having, either we can select from nums1 or we can select from nums2, or we can select from both of them, as I had shown you in the example, right? In example 1 and example 2. So like that only we are having options that we will be selecting, and even we are required with the maximum dot product, right? So that's why I am doing with the maximum, that whatsoever option was stored previously is that maximum, or the new which we are calculating, that is maximum, that is nums of I minus 1 into nums of 2 j minus 1 plus recursion of I minus 1 j minus 1. So basically we would be multiplying the present nums1 and nums2 numbers which would be there, and then adding up the recursive call for the previous one which would be coming up. That is what else which we can exactly figure out that is it basically giving us the maximum output or not. So that's the thing which we would be doing here. Now next option is there. We will be selecting that was the option 2 which was earlier stored, is that maximum, or the one which now we would be going ahead with this particular recursive call, that is not selecting the first one but selecting the second one from the nums2. So that's why we are doing this. And third option is that either the option 3 itself is the maximum, or the recursive call which will return us the answer after selecting from the nums1 and not selecting from the nums2. So this is the thing. So here the things are that either both of them are variable. So either first one is the variable, that is first one we are moving ahead. So here option 2 is there, but here also one condition is that if the I is basically greater than 1 or not, then only we will be going ahead. And here also we are having, because j minus 1 is there, so it will also only go in that manner when j is basically greater than 1. So that's why we are taking second variable part, that is this one. Now these were the options, right? And these options are basically also somehow reflecting towards our recurrence relation itself, because our recurrence relation would be somehow like this only, and then at the end we would be returning maximum out of all these three options, because at the end we require the maximum dot product, right? So maximum dot product would be returned out of these three only. And then our base case is basically when I equal to 0 or j equal to 0, then we would be returning 0, because as multiplication with 0 is always 0, right? So that's the reason in this base case we are doing like this. So this is how our recursive solution would be. And then comes the part for memoization. So memoizing this particular, we can clearly see that there are two variable parts, I and j, right? So that's why we would be going ahead with a 2D vector or 2D array, means any 2D data structure we would be going ahead with, and according to that only we would be memoizing this particular solution. So after this, now comes the part for the bottom up. So for bottom up, our state would be TP of n into m. That is the last one which would be there. That would be reflecting as our answer. And the transition would be somehow same the way we were doing in our recursive. That is the first part which was there, that we would be choosing the first from the nums1, first from the nums2, that we would be choosing. And as this would be a loop, so in that loop only we would be going ahead with all the selections of by basically making both of these as the variable. And now comes the part for nums_i minus 1 into nums2j minus 1. So for this particular, we are basically choosing this one also and then adding up what was stored in the previous answer. So that's the thing which we are doing here. Or we will be checking that when making the first one only as the variable and keeping the second nums2 as the fixed part, so then at that moment are we getting the maximum answer or not? Or if we are keeping the nums2 as the variable part and nums1 as the fixed part, then at that moment are we getting as an answer or not? So this is how we are checking for that out of all these in which we are getting the maximum. So this was about the approach of doing this question. Now let's directly head over to the coding part of this question. So here it is. So first let me show you how recursive solution is like. So basically in this recursive solution, how we would be going ahead is that here we are not doing in the main public function which is there. We are just calling a recursive function where we are passing with the nums1, nums2 input vectors which were there with their size, means size of both of them. And then here in this recursive solution, what we are doing, we are taking three options, basically all three options which I have shown you in that recursive solution. And in that the base case is this one, that either I equal to 0 or j equal to 0, we would be returning 0. Then in the case of option 1, we are simply checking the maximum of option 1 or nums of I minus 1 into nums of j minus 1 plus what were there to be given to us from the previous recursive call. And then in the option 2, we are first checking that if j is greater than 1. If it is, then we are checking for what is being there in the option 2 and what is being returned by this recursive call. Out of them, whichever is the maximum, we will be storing in option 2. And then for the option 3, we are checking I is greater than 1, then only we are checking ahead. And at the end, we are returning with the maximum of all of them. So this is how we would be going ahead with the recursive solution. Now comes the part of memoizing the same. So for memoization, we are taking a 2D vector. So for that 2D vector, the first thing is that we would be resizing it. So this is how we are resizing it and taking the size +1, and +1 is for our base case, and we are initializing with int min. That would be acting as our flag, that if it is not int min, then surely there is some some answer stored. So whole solution is as it is, the way it is in recursion. Only part which is changed is this memo part, that if it is not equals to int min, that means that surely there is something stored, so we will be returning that. Else we would be storing in memo of ij, and same goes for this option and same goes for this option. And at the end we would be returning the memo of ij, just because of the fact, because memo of ij itself would be storing the maximum out of all three options. Because earlier what we were doing was, we were directly having the option 1 and the option 2 and the option 3, right? And we were figuring out the maximum out of option 1 and what is being stored in the present one. But now we are figuring out that all in this single line with the memos. So that's why the maximum answer would be itself stored in this particular. Now comes the part for the bottom up solution. So for bottom up solution, here just figure out with this particular, so that there is no error for that memory and so on. You can clearly see here the ranges which are being there. So according to that only, here the ranges is like 10 raised to power 6. At max it could go, right? So that's why we have taken the infinity as 10 raised to power 7, just for just one step ahead of the 10 raised to power 6. And then what we are doing is, we are just taking the size, and then here we are, earlier we were initializing with the minus infinity only, right, in that memoization part. So here also we are initializing with minus infinity, just for acting it as flag rather than choosing 0 or -1. And then what we are doing next is, here we are starting from the start. Earlier we were starting from the back side, right, but here we are starting from the start, and here also even we are starting from the start, still we are starting from I equals to 1 and j equals to 1, so that here we can figure out with these parts. So here the thing is, in our nums array itself, whatever would be stored at I minus 1 and j minus 1, that would be written here, means multiplication of both of them, and it will be also figuring out with these things, that adding up into the minus infinity or giving with the minus infinity here or minus infinity here, whichever is the greater of all of these, that would be basically returned, and at the end the answer would be returned as this. So this was what for this particular question. And now comes the part for the time complexity and the space complexity. So in recursion, you can clearly see that how many options we are having. So basically we are having here with 3 options, right? So that's why the time complexity here would clearly become 3 raised to power n plus 1. But again the thing is that we are choosing from either nums1 or nums2. That is, either we are including or we are excluding. So that's why choices are among the 2 things only. So that's why rather than 3 raised to power n plus 1, it would be 2 raised to power n plus 1. So that's why the time complexity for the same would be order of, basically power of 2 raised to power 2 comma n plus 1, n plus n, and the space complexity would be order of n plus n. So this was for the recursion. It is not moving. Okay. Okay. It's not moving because of this. So this was for recursion. Now comes the part for the memoization. So for memoization part, the time complexity is basically order of n into m. That is because of the matrix which we are taking, and the means the loops which would be there, that would be in that manner, and the space complexity would be order of n into m. That is again because of the matrix which we are taking, and the same goes for the DP question also. So this was all for this particular question. I hope you like the explanation. If you like it, then do like and subscribe to my channel, and also do share it if it added value to you. And one last thing is there, that this channel is basically supported by Newton School, and the thing is that a lot of students ask me about if there is some structured course where live doubt solving sessions are there, one-on-one interaction is there, one-on-one mentorship sessions are there. So I would recommend for the same for Newton School. And one of the best part about the courses of Newton School is that there is no upfront fee. You are required to pay the fee after you have done with the course and you are being placed, and their placement starts from the 5 LPA packages to 40 LPA packets. So that's why you could easily get placed at max of 40 LPA, and after that, after being placed, then only you would be paying for the fees of the course, else you won't be paying fees for the course. So this was all. So yeah, thank you.